and then you close. Now you can close the web page, and you can, I don't know what that is.
Did you want a
so there you have
machine
it.
and a
There's the
Raspberry
icon.
Pi to get started today, or you just learning the place out?
Yeah, I'm kind of interested in his
And,
project,
yeah,
so I'm
say
just
it's
going to
fine.
watch him.
Okay.
Thanks.
Yeah.
Yeah.
You're on public network, so that's fine.
Yeah.
Yeah, see allow access. Okay, so widen this out. Well, not that big, but okay. Just make it a little bit bigger to see. Okay, so this is your IDE, Integrated Development Environment, okay?
Oh, that's what it stands for?
Yeah. Okay, so the basis of the Arduino simple software development environment is that it uses two fundamental concepts that are basic to just about every piece of code that you would write for an embedded system. There's a setup area that says, this is a one-time operation that I do all of my initialization processes. I'm going to tell the computer which pins are going to be I/O, which direction they're going to go in or out, if they're going to be, PWM or digital control, or if they have analog capability, I'm going to make them analog active or something. If I have a serial port, I'm going to set the baud rates and all the other. Basically, it's your one-time configuration setup operation. In lieu of a config file or anything else, you do that here in setup. So setup is one time. That's all. It goes in, it comes out, and it's done. Okay. It is a function. It's called by the microprocessor. So you can't do any things like waits and long delays and stuff like that because it has to leave. The processor core is here and it's going to call the setup function. Just like in a regular computer system running C, it always looks for a main function. Okay, so the operating system or the BIOS is saying, okay, I've done my memory checks and everything else. I now jump to main. And if you don't have a function called main, your programs don't run. Okay, unless you do some other configuration stuff. There's a way to get around that. But essentially, that's what we see. So in this way, this simplified system is, it's going to say, okay, I did my memory check and all this other stuff. I'm going to call setup. So it's going to run down through setup, and then it's going to come back. It says, okay, setup returned. Everything must be fine. I'm now going to call loop. And then I'm expecting loop to exit and come back to me again. Then I'm going to call loop and exit and come back. And loop, exit, come back. And that's all it does for the rest of its life. So your loop function cannot have anything that says, wait until he presses a key. Because it's just going to go out, loop, and sit there waiting for somebody to press a key. But if it's relying on some other activity, such as the timer going off or something else, or even detecting the switch, you may not exit at all. So the worst thing you'd ever, the minimalist thing you could probably do is have a delay function in there. Like go out here, blink the LED, wait a second, 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 and then come back. Okay, but now you've basically hogged up all the resources for 3 or 4 or 5 seconds, and it's timers inside where it's like keeping track of the clock and everything else. They haven't been doing anything because you've been sitting out here taking up all the time. Now, sometimes they have the delay will actually let it do its things while it's in delay. There are ways to get around that. You can actually look at the timestamps. Okay, so you're doing fast loops all the time, and then only do things when the time says, oh, I've been looping around for the last 300 milliseconds, I'm now going to do something. That's much better than saying stop and wait 300 milliseconds and then do it. So, but that's just programming things to get into. So, but the fundamental thing is, it's going to call setup once, it's going to call loop continuously. So, make sure your loop always has an exit, that it can never lock up. Because if it locks up, you're going to mess up everything else, like your serial outputs and everything else. Okay. So, now, as for your homework, you go here to File, and under File, there's Examples. And see all these examples? Well, notice those have little arrows, and those all expand into even more. Okay? That's why I say there are hundreds of things to look at. So in your free time, when you got half an hour and nothing to do, you should scan through these examples and and just kind of look and see what's there. And if you have an idea to do something, you'll probably find an example that already does it.
And when you add libraries, it adds more examples too.
Yes, it does. Okay, so there is a library management system. You can download libraries as zip files or as lib files or other things, and it's very nice and seamless on how it puts things together. Okay, the second piece of information, which is just as critical, is you go over here to your help window, and you go to reference. Okay. This is your library reference for the language that is currently in the Arduino. Okay. If you scroll down here, you'll see all these various functions. Like all the digital I/O is handled by just these three functions. You tell it what kind of pin it is. If you were to click on that one here, it says this function describes the pin. It can be set up as an input, as an output, as an input with a pull-up resistor. Okay. Various, and then now if you scroll down a little bit, it gives you example code. Okay, which is kind of nice. So it gives you an example of how to use the function. Okay, so let's back out of that. Okay, so if you want to, again, if you have an hour or more to spend, I would go through and just peruse all of the various topics in the reference manual.
Yeah.
Okay, that's the starting point.
Oh.
Once you're bored with that, then you click over here on the libraries. The libraries, scrolling down, you'll see that there are lots and lots and lots of libraries. There's the standard libraries. They give you EEPROM. This device actually has 256 bytes of EEPROM that you can. It's like semi-permanent storage. So it's like your own little disk drive, very small, but you can store things and they'll stay there. Okay. GMS if you want to do cell phone things, liquid crystal display, SD card interfaces, servos, SPI interface, serial interfaces, stepper motors, Wi-Fi, wire, that's for TW, that's for I2C kind of thing. And then you go down farther, and then there's libraries that are specialized to certain types of special devices. This is like when you're really, really bored. You look at this stuff. But I would pay attention to the standard libraries. But there's a ton of things in there as well. Okay, so again, if you wanted to hook up an LCD display to your Arduino, there are like 2-line by 16 character LCDs that hook up using 7 lines of your I/O. You just slap it on there, run the driver, and you can display things in your LCD display. There's TFT graphics, little 256 by 256 or 256 by 128 little graphics displays like for a cell phone. You can hook up to these guys. There's a driver you can download. They connect through SPI. You can have animated graphics. They look really nice. They're small, but they're really nice.
Does it drive VGA too?
No.
Too big, yeah.
It's the outputs are digital, so these modules are designed specifically to fit the Arduino footprint and to interface to the digital I/O pins that it has there. But anyway, as you look around the internet, there's tons and tons and tons and tons of stuff. Just doing all the sensor kit in here, okay, like how would you hook up this little joystick? Well, this joystick is an analog joystick. It's got 2 little pots, okay? So you have 2 wires here, they go, one to each analog channel. There's a voltage and a ground, okay? The other one's probably for when you push this guy, you can have, there's a little button off to the side. And then there's a button switch. That takes up the 5 pins, okay? So we could hook this guy up to the Arduino. We would declare 2 pins, 2 of the I/O pins, or 2 of the analog pins as active for analog input to read voltages. They read voltages from 0 to 5 volts, or 0 to 2.56, or 0 to 1.1. There's ways you can set the voltage level, what to do. We put the VCC pin to 5 volts. We say the analog is going to be 0 to 5. We set the switch one to one of the I/O, digital I/O pins to say detect input with a pull-up resistor. And there we go. Now you can hook this guy up and run it around. And then we could hook up a motor using one of the other pins as a PWM, pulse width modulation, that gives you kind of a duty cycle to the motor. It makes it go faster if it's all on or slower if it's all off. And you could have this guy controlling the speed of the motor or anything else. But those are, again, lots of stuff. You got tons of things to play with. You will stay busy for years and years and years and years. Okay. So, anyway, you got a new toy.
I do. I can see it. Yeah.
And they give you all kinds of neat stuff. In
Oh,
here. Yeah.
this I saw it,
Oh, oh, you bought the 37 sensor kit. Oh, you got a ton of stuff to play with. You have, in fact, there's you have a DH11 sensor in here someplace for humidity and temperature.
oh, I do?
Yeah, right here, this guy right here. Okay? It's an 11 or a 22. Have to look in your manual. Okay, but this is a humidity and temperature sensor. Has a digital input, and you read it in serially, and then you parse it off. You know, like the first byte might be the temperature, the second byte might be the humidity, or 2 bytes of temperature and 2 bytes of humidity, or whatever. I haven't looked at the protocol in years. Anyway, but that's what this guy is. Then you got a microphone. Then you got a laser. Ooh, you got a little laser emitter. That's a laser diode.
Yeah.
Okay, so you have a laser diode, and you have an IR detector. Actually, this one's just a regular photocell detector, but you put these guys together and you make a communications if you want to. You got a button, you got LEDs, you got
Christmas again.
line followers, you got a microphone preamp, you got tons of stuff in here. Lots of toys. And you got a keypad too. Now the thing is, you can't hook all these up at once. Because you're
I'm not that
No.
fully
That's one of
awake.
the parts of the summer of it too. It's
All
just
my
like
life.
This
sometimes
guy
it's
here-
like one thing at a time.
yeah, this is an Uno, and you have basically 14 I/O pins.
Oh.
Plus 6 analog pins. And there's your development board. Okay, so everything's to play with. There's another one in there someplace. So you have to mix, basically, the only thing that's gonna stop you from doing a lot of stuff is the limitations on how many I/O pins you have. You only got so many to use, okay?
There must be I/O expansion board.
It's probably-
There is I/O expansion. What it is a shift register or selectable latch, and you basically you take 8 pins and let's say a couple other pins for addressing purposes, and you can address an IC. Okay, well if you have 3 pins here for address, that gives you 8 possibilities, and if you have 8 pins here, that gives you 8 parallel pins to the device. Okay, so I could take one of these and have 8 pins, no benefit. But I can put another one on here and have 8 more pins. And I use my 3 pins of addressing to tell me which one I'm talking to. Then I put another one over here, and another one, and another one, and I have 8 of them up here. I now have 64 pins of I/O. That's how you expand it.
Sounds like a fun project.
So you have digital expansion
maybe.
if you need to.
If we ever go to spaceship, he's the one we have to take.
So, but that's electronics. I mean, that's the stuff you will learn either here by talking to me or Thomas or somebody, or you look in books like this, and there's a whole section on digital I/O and how to use digital devices. Okay, it's a little dated, but the fundamentals haven't changed in 20, 30 years. It's still digital I/O, and this guy's also a good book to do that stuff too. Or you just say, hey, I'm running out of I/O, what should I do? Okay, well we talk about doing smart sensors, like I propose I2C. Arduino doesn't have any problem using I2C in software smart sensors. So all my stuff, like my little robots and things, I use I2C, which is a Philips network protocol, which just uses 2 wires and plus power and ground. And it sends serial commands to all the devices. And you can have up to 256 in theory, but actually I think 198 because they have reserved from addresses for things. And you just send things, and it works at 100 kilohertz or 400 kilohertz serial rate, so it's very fast. And if I want to distribute a bunch of things around, I just make little I2C modules and then hook them all up, and then I just send streams of information. It addresses whichever one it goes to. So that's another way to expand your I/O. Most of the stuff you build is going to have a response time less than a millisecond. Okay, that's 1 kilohertz. Okay, so you can even run serial 9600 baud and meet that specification. Okay, so running I2C, which runs 100 times faster, but again it's 10 bits for every cell, so it runs actually 10 times faster at its lowest speed, faster than a millisecond. So you can get pretty fast update rates using all of these trivial basic interface systems to expand your I/O or to talk to multiple devices. Okay, and the way costs of most things are, these little microprocessors, 50 cents. Okay, you just
50 cents.
String them, yeah, that's what my little AVR tiny 85s are. You know, they're that cheap. It's the hardware you put on, the board you have to put it on costs more than the processor itself. Okay, so for less than $5, you can do just about anything. You can get those guys Arduino-based systems. There you go. Okay, and then Gabe's got a couple of these. This guy is an Arduino Nano. It's the same thing you got.
Really?
Yes, except that it has the same number of I/O pins, and it runs off a foam charger, 5 volts. Okay, rather than your guy which runs off 9 volts and has voltage regulators and everything else. But it has the same number of I/O pins. Okay.
Then why do we?
Well, this has other options to it. Oh, you got it there. Okay. Okay. So see this one. To talk to this guy, you have to have a USB to serial adapter cord.
Oh.
Whereas this guy will hook up directly to your laptop. This one has a 7 to 12 volt input for voltage, which it regulates down to 5 volts. Okay, so this has more things on it, make it more flexible. This is after you're done developing on that, and you want to build a project cheaply with this, you run the same code. Okay, so it's the next step. It's productize here, whereas develop with that. That's easier to develop with. This is cheaper to manufacture with. That's all. So those are your options, and that's where the same thing with the Raspberry Pis. They have the Pi Nanos and all this other stuff. They're all just cheaper versions of the same thing, but they took out all the stuff that people don't need because it's a specific application. Okay, so if you want to manufacture something,
This is called what?
this is called an Arduino a Nano.
Nano.
Arduino Nano. They're about $5. Okay, you buy them in quantity for 4. You know, if you buy 20 at a time or something like that. Gabe has them stocked up in here, so. But it's just this is an advanced thing, something to do later, because you got to adapt. You got to account for the power supply and everything else. So when you add the voltage regulator and the supplies and stuff, or you buy a 5-volt power supply for this, which I have, they're like $250 a piece. So, you know, it's all mix and match. So, but playing with this guy, that IDE is your window to the world, and you're windowed inside this guy. Now, generally, the very first thing you want to do, okay, what's nice about also this is if you hook up you got the USB cable? Oh, here we go.
Yeah.
Okay. This will power itself off the USB
Oh,
without the external voltage, yes.
Oh.
So if you load a program in here and then take it off the USB and put an external power supply to it, it'll run the program. Or you can run it directly off the USB drive. Okay, so just hook this guy in there. Yeah, it just plugs in one way to go. Okay, stick it in USB. And what's going to happen, you're just going to see an LED on there and it's going to start blinking at you.
It shouldn't touch you, right?
Yeah, that's again another reason why to have either one of those boards that Gabe has, or mount your own on a piece of wood. Either way. Okay, so there you go, and you're now running a program. See, it's blinking. That's actually a program. Now,
This is setup?
it has a program inside of it, just to give you
Oh,
confidence
I see.
that the board is working.
Oh, okay.
However, okay, so let's close this and go to the IDE. Okay, so what you do, the very, very first thing after you get a board, you go to File, and you go to Example, and you go to Basics. No, Basic, down one more,
Down one more.
Whoop.
Oh, okay. 0,
Basic
1 basic.
and Blink. And you click on Blink. Now, you can close this other window now, 'cause you're not doing that. Okay, now, this is an example program. It's called Blink. And in fact, that's what it's running right now. So the first thing you want to do, this is sitting in your examples folder of your installation. You want to save this someplace else, because we're going to make some changes here, and we don't want to modify what the manufacturer gave you. Okay,
Right.
So the first thing you do here is you go to File and you say Save As, and pick wherever you want to stick it. You can stick it in your Documents folder, you can stick it in Users folder. I have special folders set aside and based on my configuration. So put it someplace that you can find it. If no, I stick it in your Documents
Okay.
or downloads, or
Arduino program.
you could make a new file called Arduino Programs.
How do I make this one, right?
Yeah, new file. Okay.
What do they call these scripts?
This yeah, they in Arduino they call them scripts.
Thanks.
It's a program,
Yeah, it's a program.
but they
just-
call them scripts.
Italians. I don't know. Okay, so open up that folder and then give this a name and say like Blink Test or something. I don't know. Or Test 1 or okay, good. Now we're saved.
I wonder because it has
Okay,
to go
yeah.
through.
Okay, so to give you confidence that this is in fact working and you are master of the hardware. Okay, scroll down here. You can actually open, widen, and pull that down a little bit. Okay, you want to leave this area at least that big because that tells you error messages and other things. So, yeah, that's good. Okay, so what is this doing? As I said before, it has a setup, right? And it has a loop. Okay, so the setup, and what's nice about these guys, they usually put some comments in their code to tell you what they're doing. Okay, as Lewis and other places. Okay, so the first thing they do is they call this function called pin mode, and they give it two values. They give it a thing called LED button, and they give it a value called output. Those are literal defines. This LED button actually means 13. Okay. If you were to go, we could search through and find out where it is in fact defined. It's in a header someplace, but it actually just means the value of 13.
Okay.
The output is probably a value of 1, because generally when you set the I/O pin to a 1, it becomes an output. Those are guesses, but for your purposes, you don't really need to know that much about it. However, what you could do is you could go to that help reference, and where you're at that digital I/O, the very first time you went there, and I said, this is pin mode, this is pin out. Okay, you can look up this function, and it'll explain to you exactly what that function does, and what the values are that you can set. So just go help and reference,
It's not connecting.
Oh, it's not. So
So you
probably
gotta-
now it's the same
and over
competition.
there,
Thing. Okay.
digital I/O,
I
pin
can
mode.
plug it.
Just click on that, and it gives you description, sets the specific pin hardware and things like that. That's the syntax, which pin you're going to use, what mode of operation it's going to be in. Pin is the number of the pin, and mode is input, output, or this. And we've set it to output, okay? And if you scroll down a little farther, there's a little example, okay? And it looks just like the one we've got, just about, except they're using a different name for the pin. They have a define up here, and then they stick it in. So they're using pin 13, we're using pin 13, but we're using an internally defined literal that does that, okay? That's why I say, you want to go back, whenever you see something you don't understand, you go to the reference area, and it'll explain it to you. Okay, so let's back to the hardware thing.
It's good.
Okay, so
Oh, there it is.
now the rest of this is a very simple little code, pretty straightforward. Turn the LED on, wait for 1,000 milliseconds, turn the LED off, wait for 1,000 milliseconds, and then exit. Then it's going to come back in again and keep going over and over. That's why this is blinking. Now, how can we verify that? Let's check one of those and change it down to like 10 or 100, either one. Take out a 0 or 2. Okay? Now we have a much shorter delay, right?
Okay.
Gonna blink faster.
It's going to either stay on it's going to stay on shorter, or it's going to be off shorter. But it's going to blink differently, right?
Right.
Okay, so now to do this, we do the check mark. Oh no, you don't want to. You don't want to change them both. Don't change them both.
No.
Change only one.
Change only one. Okay.
Okay. So now go up here and hit the check to validate that you didn't mess up anything. It'll compile it, and it should come down here and it'll tell you what your resource usage is, like how much RAM and how much ROM was used. Okay, then you click on the little arrow here. That's your download arrow. So we're gonna download this code into this device. And that LED is gonna blink differently because we've changed it, right?
It's got a lot of limited qualities.
Okay, uh,
Serial.
okay, so we skip print, okay, so you can say okay for that. Okay, now, while but you can see it's blinking differently. Okay, so it's only staying on for 10 milliseconds, but it's staying off for a second, so you're getting blink, blink, blink.
Oh,
right?
I see, yeah.
Now, let's look at that, what that error was caused by. Under tools. Okay. What you want to do whenever you have a board hooked up to your IDE, you need to tell the IDE what kind of board you're using and which COM port it's connected to. That little error message you came up with is so common, they made it as a pop-up to help you configure the thing without having to look at this stuff. Okay, but what you would do is you go down here to board, okay, and you see these are all the different Arduino boards that you could have connected to.
Wow,
Okay.
this many variety?
Yeah,
Wow.
lots of variety. See, there's the Arduino Nano, so if I took that little one and hooked it up here, we use that. We have the Arduino Mega, that's one I have on my board, but you're using the Arduino Uno, right? Arduino Uno. So that's fine, so you're set correctly. And then port,
Oops.
if you go down to port,
Board
next one
and
down.
board.
Okay, it'll list all the serial ports that are currently being used by something.
Okay.
Now, if you had something else hooked up here, it might be COM port 8 connected to printer. And then you'll see COM port 9 connected to the board. You want to make sure it's got the check mark next to your Arduino COM port. That's what that little pop-up says. It says, we don't know which COM port you're connected to. We assume it is COM port 9 because that's the only one being used. And you said yes, and let's go.
Okay.
So that's why it's set that there.
Okay.
But if you ever run into problems where the board isn't talking, the IDE doesn't seem to be communicating correctly, you want to go to the tools, make sure the right board is selected, make sure the correct COM port is selected as well.
Right.
And that'll usually fix 99.99% of the problems. Okay, so that's done. Now, okay, so you're set up correctly. That's just board information. You'll get that if you're connected correctly. Okay, now, so what are some things you could do here? You could, right now you've got this thing only blinking 10 milliseconds for every 1,000 seconds, right?
Right.
Well, you could change that 1,000 to actually be a random number.
Oh.
Okay, so let's go to this, here's how you do that to play around. Go to help, go to reference, okay. Scroll down until you see a function called random. Keep going. There it is.
Random, yeah.
Okay, so let's take, okay, so it's just random with nothing. Actually, it can actually take a seed value if you wanted to. But random parentheses is what you want to use, okay? Okay, there are random min and max. Okay, so probably random max or min max, either one.
Okay.
We'll use one of those. Okay, so let's go back to the code. Just click in the code. Okay, so type in here, instead of the 1,000, we'll change that to random. And we'll say parentheses, something between 10 and 1,000. So 10 comma 1,000. That means give me a random number between 10 and 1,000.
I'll put 1,000 so I can see
Well,
differences.
okay, if you put 1,000, it's going to say that's the maximum value.
Yeah.
It'll say random number from 0 to 1,000.
Yeah.
Okay, yeah, it's
So I see more
It-
variations.
10 or 0 is not going to but
You want
but
me to try
could.
100?
No, that's fine. No, that's fine. 1,000.
is fine.
1,000 is good.
1,000 again? Yeah.
Okay, now you need to add another parentheses because you have an open parentheses here, right?
Oh, I see.
And you have the parentheses
I have to match
for
the
code.
open one
Yes.
and
Oh, you got to match them up.
right.
Okay, so do your check mark for
Check mark to
assembly.
verify.
Okay,
Oh, it's called
so it'll
assembly.
compile, and it'll no errors. And now,
Yeah.
okay, so now download. Okay, now your light
Mm-hmm.
is randomly flashing.
Mm-hmm.
So it's staying off a random time, but every time it turns on, it only blinks for 10 milliseconds. But it's flashing every so often. Now, if you mix and match the random number with the amount of delay and the amount of on time and off time, you can make it flicker like a candle. And by using that min and the max, you can get it to be really look just like a candle. Okay, so that's how they make the little flashing red LED candles that they put on
And
birthday
turn
kids.
that into the Arduino
And you put
nano.
and yeah, put it in a nano, and then you got this little box that kind of flickers like a candle. Toys to play with, okay? Not really practical, but
If I put
you can see that
my sensor here, it will be on.
you could easily test. Okay, if you go to the and it says under inputs, there'll be button inputs, sensor inputs, all these other stuff, and it will say if you wire it up this way, and you measure the I/O line, whether it's high or low. When the I/O line is low, you may turn the LED off. When the I/O line is high, you may turn the LED on. That's how you detect, the open and close of the sensor. Because as we've shown there, when the wire is closed, it's 0. So when it's open, it's high. So when the magnet is next to it, it's open the sensor. So you're going to see a high all the time. When you take the magnet away, then the reed switch is going to close, okay, which is going to be a ground or a low. So you look at the I/O line. Is the I/O line high? Door's closed. If the I/O line is low, door's open. Then you say, okay, if it's open, I light the LED. If it's closed, I don't. That's how simple the logic is. Or you output a serial command to a Raspberry Pi or something, or some of the display, and it says, or maybe you put on a GSM connection that sends a fax, a message to your phone. It says your door opened. You can do all those things, okay? But you have to buy modules. You have to buy a cell phone GSM interface module for that. But they're on the internet. No, it wouldn't be in one of these.
No.
They're kind of expensive. And then you've got to register with a cell phone provider to give you a little chip to use to get you onto their network and other things.
They're not as expensive as they used to be.
No, they're a lot cheaper now because there's a lot of people doing it.
They're like $15 now.
Yeah, that's good. But before it was like hundreds.
Oh,
Pay
yeah.
monthly though?
Yeah,
Well, I mean,
Some-
it's a cellular service. It's
Yeah.
the same as like your phone.
right.
I mean, you can do pay per text, right?
Yeah, minimal. Yeah, low bandwidth and all this other stuff. It's negotiable, but it's not
not free.
arduously expensive.
Yeah.
But anyway, so you now have control of the machine. You are now free to envision whatever you like, and as long as you can tell it in C code what to do, read inputs, output.
This is C?
Yes, this is a kind of a bashed up C++. This will actually do object-oriented coding systems in here. You can make classes and objects and instantiate stuff. But for the most part, most people just use it for C. When you get a little beyond this and it becomes too cumbersome or too constraining, then we move over to Arduino Studio. Android Atmel Studio.
At Mills.
Yeah.
Yeah.
And you can program this ATmega 328 chip directly without having to use the Arduino operating system. The advantages are you now have control over all 3 of the counter timers that are inside the chip. You have discrete control over any of the I/O pins. Okay, you don't have to fight with their timing or any of the other stuff. You have absolute control, and you can run the thing at 20 megahertz instead of 16. You can run it faster. You can run it slower at 8 megahertz. Anyway, more flexibility, more power, but more complexity in understanding how it works. So you start with the Arduino, and you get very comfortable with that. And I can show you it's like a half step to use Atmel Studio and program your chips directly instead. The little line follower robot and all those other robots and boards in there, they're all programmed through the Atmel Studio using a in-circuit programmer. Okay, in-circuit programmer can cost you up to $100 because they don't make the cheap $45 one anymore. So it's more expensive to get a development setup going, but on the plus side, I can make little boards for a couple of bucks that do everything this does. Instead of paying, $25 or $20 or even $5 for a Nano, I can make all my stuff here is all custom. So that's what I do.
Now I feel like I have to live longer.
You'll never run out of things to keep you busy. Don't worry about it.
Okay.
Okay. I still haven't explored all the possibilities of what my stuff can do. I just wait until I need it, and then I look into it. So, but that's, you know, it's playing with toys. What can I say?
My age, I get emotional now. So,
You got, I mean, you can wow your kids and nephews and nieces with all these sensors that you have here.
Oh.
Okay, you got motor control, you've got stepper motors, you've got LEDs, you've got, that's a motor control. There's an I/O expander for you.
oh,
You have an IR control, there's an IR receiver here, so you can sit back here with your little IR remote and command your board to turn things on and off remotely with an IR. Okay, your proto board, you got lots of LEDs, you got red RGB LEDs, you got diodes, resistors, you got the little thermal sensor, you got temp, you got all kinds of stuff. And then you got this guy here, which is even more stuff. Okay, so you got more toys to play with. Just tons and tons and tons and tons and tons. You keep you busy for a long, long time. And if you run out of stuff, I got stuff here and I got stuff under there. You know, I got a 24-bit A to D board there that you can do strain gauge sensors with. It's that accurate, that much resolution that you can do. You can measure, you know, like how weight scales work and stuff like that. And I have a gas sensor too, a gas density sensor. All kinds of stuff to play with. Yep. Toys. It's all toys.
So, so you could have your alarm system arm and disarm with either punching in a code or
Sure.
an IR
Oh yeah.
Yeah.
button.
Or Wi-Fi or anywhere else. You
Or
can-
your phone.
Or your phone. You can run an app for the phone. Turn it on and yeah. All those are available to you. If the interface is there, you can do it. So I mean, there's tons of stuff on there how to go through Bluetooth to your Raspberry Pi from your phone, iPhone app, how it to talk to you. You can have it send you text messages when it, you know, if it's connected to the internet. Okay.
Yeah, having a button would be nice. Of course, you still need the code as a backup in case your battery went dead on your
Oh, yeah.
IR.
Yep, yep. No, that's all considerations
Yeah.
for product development. You have to take all those into account.
Nice.
So it's open to your imagination. It's like, really. And like I say, if Circuit Seller or Linux Magazine, Linux Format, looking through there, just Googling, you'll see tons and tons and tons of people who have done similar things, and you just mix and match. I mean, right now, very few people write code from scratch, except for silly like me. Even I take stuff that I wrote years before and use it as the basis for starting up new stuff. I rarely have to write anything from absolute scratch. Okay, I do occasionally, but not very often.
Yeah, when I first started my business 24 years ago, I wrote my accounting software,
Yeah.
you know, for all my collections and accounts payable and bills and everything.
Yeah.
But then I found QuickBooks and I'm like, oh, I could never match this.
No.
You know, and I switched. But for years, I wrote my own
Oh
software.
yeah, people they'll use Excel for doing all their books and stuff like that for a long time, and then they'll learn VB Basic and write scripts and macros and do all these really esoteric things, and yeah, then they'll discover QuickBooks.
Yeah. It was a lot more fun writing it.
Yeah.
And it did everything exactly the way I wanted. You know,
Right.
the printouts were formatted exactly the
Yeah.
way I wanted it. 'Cause, you know, you have more flexibility that way. But
That's the advantage, but the disadvantage is you could make a mistake, it could be a bug, you know, and you gotta support and maintain it.
oh yeah, that's the fun part though. Yeah. Well,
Until you run
back
out of
then when I
time.
had time.
Yeah,
yeah.
you run out of time.
I had time back then. Time is the issue now.
Anyway.
Which I gotta go
Awesome.
do other
Yeah.
stuff now.
Mhm.
But thank